Good morning, good afternoon, and good evening to you all. And hopefully you've had a pleasant day today. Anyway, we have done series circuit, we've done parallel circuits, and now for our last final countdown, we shall end it with combination circuits. This is a bit of a tricky one, but it's pretty self-explanatory. And anyway, let's begin, and hopefully you understand it, because it's actually really easy, simple stuff. So, let's begin. Let's draw a battery. I'll go far left as possible because I want to keep some space. It's going to contain a lot of numbers and values and diagrams. So, here we go. We'll draw a battery. Whoopsies. Resistor there, another resistor there, and the resistor there, another resistor there, boom, another resistor there. It's a bit sloppy, but hey, who doesn't like a sloppy drink? I don't know. Yeah, Milo's pretty good with marshmallows, but I don't know what your, calories would say to that, or if you want to keep healthy, just drink some water. Okay, that's probably the best thing to do. So with our first resistor, we'll give it some value. Well, we'll go 8 ohms, we'll give that 5 ohms, we'll give that 8 ohms maybe. I don't know, I'm really bad at making up numbers. 15 ohms, 20 ohms, we'll get that one 30 ohms, and we'll make that power supply 15 volts. To work, okay, to begin with, we know we should work out the total resistance, so let's do that. And oh man, I need to move the camera up a bit so you can see the values. Okay, so to work out the total resistance, let's go back to the parallel component section course. So we need to do the reciprocal. So here we go. Let's work out the total resistance for this here. I like to draw a circle around it just to make it simple, and then I'll call it RA. So the total resistance for RA is going to equal so here is a series circuit. That's pretty obvious, right? And 8 plus 50, and we know in series circuit, total resistance is we don't need to use a reciprocal for it, we'll just add it up. So 8 plus 15 is going to give us 23, right? So 23 is going to be our first reciprocal. We'll divide that over 1, and then we got 20 plus 1 over 30. So RA is going to equal oh, I hate colds. As I showed you last time how to work out the reciprocal, you just go open bracket 23 plus, that's a reciprocal, that button there, 20 reciprocal plus 30 reciprocal, close brackets, and we'll use a reciprocal again. But we're not working out conductance, so that's why we do that. So it gives us 7.88. It's 89 ohms. We'll round it off. So there we go. Now we know that that's going to be a series. Well, if you look at it like this, we can redraw that, and it's going to look like this. We've got the battery here. We've got resistor there, and this is RA resistor. Just imagine, okay? Use your yes, imagination. So we've got 8 ohms, 5 ohms, and we got 7.89 ohms. Now this is a series circuit, so what do we do with a series circuit to find the total resistance? Well, we just add them. Simple as that. So we just go RT is going to equal 7.89 plus 8 plus 5. So that's going to give us 13 plus 7.89 It's going to give us 20.89 ohms. Pretty simple. So the next thing we're going to work out is the total current. So to find out the total current for that circuit, we're just going to use basic Ohm's law like we did last time. So IT is going to equal 15 volts divided by total resistance, which is 8.9, 20.89 ohms. IT is going to whack that into our mystical calculator that gives us crazy numbers. It's madness sometimes. Oh, we don't have enough space, but yeah, that's going to give us IT is going to equal 0.712. We'll round that off. Amps. So that's the total, yes, current for the whole entire circuit. Now we're just going to do some, we'll give that some R1, R2, R3, R4, R5, R6. So now we're just going to do work out some voltage drops. But my question is, what is the voltage from R3 to R4? I should have wrote a question like that. Okay. What is V? I will just make it what is VR4, the voltage for that component there. So yeah, let's work that out. So now we know the current for the whole entire thing. We can work out the voltage from that to that. For that, oh, my parents start off with finding the voltage for R1. So VR1 is going to equal what is it? 0.72 times 8, which is going to equal 8 times 0.72 is going to give us 5.76 volts. Whoopee, it's so close to 6, it's not funny. Alright, so now we found the voltage for our VR1. Let's find the voltage for VR2. That's going to equal the same thing. Well, you know, the same method. Well, but we're just going to times that by 5 this time. VR2 is going to equal 0.72 times 5, 3.6. It's so close to 4, it's not even funny. Well, okay, well I need to change that camera. There we go. Alright, so now we've worked out that. Let's move that closer to over there. So we know that's got 3.6 volts. And we know that's 5.76 volts. Okay, so let's find the voltage from VR1 to VR2. That's going to be simply subtracting 15 volts from what was it? VR1, 5.76 volts. And that's going to give us 5.76, 9.24 volts. So that's from VR1 to VR2. I mean, yeah, that's the voltage from that. Now we're going to subtract. So VR2 to VR3 to VR5 to VR6. What was that, 6 or 4? Oh, 4, 5, yeah, 6. That's going to equal 9.2 volts take 3.6, which is the voltage for resistor number 2. So that's going to equal 5.64 volts. So that's 5.64 volts going through here to there. 5.64 volts, because that's the parallel circuit. Okay, so now we worked that out. The rest is pretty simple. So to work out VR4, we're gonna have to work out the current. So IR4 is gonna equal 5.64 divided by the total resistance, which is for that, which is going to be, what was it, 15 plus 8, right? 23. Yeah. 5.64 divided by 23, it's going to give us IR4 equals 0.24. Alright, there's another way to figure out the voltage without figuring out the current, and that's called voltage divider trick. Man, there's not enough space. Alright, I'm gonna have to redraw it. Whoops, sorry. So we have, I'll redraw the circuit. Eight ohms, 15 ohms, 20 ohms, and what's the last one? Wasn't it 30 ohms? Yeah, it's 30 ohms. Yeah, there we go, 30 ohms. Whoops. Okay, so now we know the current for this section here, and we know that the current stays the same in a series, so it's not going to change. So now we just times 15. So VR, was it VR6? No, VR4 equals 0.24 times 15. VR4 is going to equal 24 times 15, 3.6 volts. Now let's do a divider, voltage divider method, and which is a lot simpler because you don't have to find the current. You just use it to find the voltage. So the voltage divider, I don't know why I can't pronounce that today, is formula is this. It's gonna R1, or the resistor that you're trying to find, is gonna be equal to R1 plus R2 times the voltage for that circuit. So, well, not the total circuit, just for that section, for that branch. So we're trying to find VR4, so we have to work. So it's going to be 15 divided by 15 plus 8, which is 23, times the voltage for that branch, which, what was it? It was 5.64, and that's going to give us V equals VR4. I mean, so it's 15 divided by 23 times 5.64, 3.68, 3.6, yeah, which is pretty good. It's close enough. 0.68. You're gonna get different results, but it's close. It's close enough. So yeah, that's a voltage divider, and that's using that without finding the current for that branch there. Now, if you want to work out the current for the second branch, what we do is, I'll show you. So was it 5? Yeah, 5. So that's 5 6 is going to equal the voltage for that branch, which is 5.64 divided by 20. IR5 is going to equal 5.64 divided by, was it 20? Yeah. Was it 0.282? Now, that's the current for that. The last current we can do just by simple arithmetic, which is going to be RI6 equals, well, we have to find the total current. Yeah, so it's going to be, where's the current for R4? What was it again? IR4. Oh, here it is. No, 0.24. So it's going to be 0.24 plus 0.282 subtract the other current, the total current for that circuit. Where was that again? Where's the total current? I can't find it. IT. Oh, 0.72. That equals 0.522. Now IR6. Man, I need to change the camera again. It's going to equal the total current, which is 0.72 take 0.522. IR6 is going to equal 0.72 take 0.522 0.198 amps. So that's a total, and if you add the branch, I'll move the camera again. If you add the branch for this, oh wait, I'll actually go back to the first one. If you add the branch for this and that and that, I mean the current for those three branches, you'll get the total amperage for the total power supply. So that's I equals 0.72 amps. I'll put up here actually. So there you go. So we found out what VR4 is. 5.6 was it 5.76 volts? Oh no, it wasn't. VR4 3.68 volts, and we also found the current for the last branch for IR6, which was 0.198 amps. So yeah, I don't know, I'll probably restructure this video again, but I'm going to upload it, and hopefully you found it informative and you understood it all, because it is really simple if you know how to do it and if you understand the fundamentals of circuits and how current flows. But yeah, it is really simple. If you want any additional help, you can email me or Skype me, and I can give you a one-to-one teaching kind of teach. I don't know, teach one-to-one help, I guess you could say. I'll be more than happy to do that. But yeah, there'll probably be another revision 2 of this combination series, because as you can see, it's very messy. And I don't know, I think I jumped a few steps, but yeah, hopefully you understood what the voltage divider method and the other method that I did, the longer method. Finding the current first and then finding the voltage, but the voltage divider, you just skip finding the current, and you can just work out the voltage by finding the R1, well, yeah, and then dividing R1 plus R2, and then timesing that by the voltage for that branch. Hopefully that makes sense. Yeah, anyway, guys and females, thank you for tuning in to my video, and stay tuned. I'll make another revision of this video. I don't know when, but we'll do it sometime. And yeah, thank you for watching this combination video, and goodbye, and see you next time. Kapow! Man, where's my finger? There it is. Yeah, it's a thumbs up, not up yours, because I'd censor that. And I'm not that harsh. I'm not that mean either. So yeah, there's all the workings out. Goodbye, and have a great day, or have a great night, should I say, depending where you are in the world. See you later. Goodbye.